Hi, everyone. Welcome to today's webinar, the U.S. Lithium Battery Market and the Challenge of Supporting It with Domestic Suppliers. I'm Shannon Reed, the Director of Community Engagement for the Electrochemical Society. Before we get started, I'd like to go over a few items so you know how to participate in today's event. You may have joined using your computer's speaker system by default. I believe there is a join over the telephone option for Zoom in the connection page if you would like to dial in for the call instead. You will have the opportunity to submit text questions to today's presenter by typing your questions into the questions pane of the control panel. You may send in your questions at any time during the presentation. We'll collect the questions and do our best to respond to them during the Q&A session after the presentation with time permitting. If we run out of Q&A or we run out of time for Q&A, we may post an ECS blog with answers to the most asked questions. Again, today's webinar is being recorded and it will be available on the ECS YouTube channel in the coming days. And we'll also post a blog promoting the recording that'll be available in an upcoming weekly e-news. To begin, I'd like to thank the ECS Northwest or Pacific Northwest section for coordinating today's webinar with
Willey.
Dr. Mark Willey. This is what makes today's webinar possible. So thank you to both Jay, who is the chair of the ECS Pacific Northwest section, and Dr. Mark Willey for the presentation. Before introducing today's speaker, I'd like to do a quick poll of the audience. Please give me a second to launch it. We are interested in knowing whether you plan to attend the 241st ECS meeting in Vancouver from May 29th through June 2nd. We know that there may be some difficulties with traveling as a result of the pandemic. We understand that we will have some digital components of the meeting, so there is a digital attendee registration rate. One other item that we wanted to promote also was membership as part of attending the meeting or getting involved with the organization. So as many of us know, ECS is a unique scientific community that can help further your research and career. Members benefit from connecting with a global network of leaders in the fields of electrochemistry and solid state science and technology. And ECS offers a broad array of programs, including, as I mentioned, our biannual meetings. We have a number of awards, grants, and fellowships, continuing education offerings, and much more. So as you look at some of our programs, in particular our biannual meetings, there are a number of other ways to get involved as well. If you'd like more about membership, you can visit electrochem.org and visit the membership tab. And let me end this poll. Thank you to everybody that responded. As I mentioned, we are having the 241st ECS meeting in Vancouver, Canada at the end of May, starting on the 29th. We do have a late abstract submission deadline. So if you didn't have a chance to submit an abstract earlier this year, the abstract submission deadline for late abstracts is May 13th, 2022. Again, there is a digital attendee option for the meeting, as well as in person. We'll have over, I believe, 2,000 abstracts for the meeting, so lots of content to consume. I'd also like to highlight the upcoming meeting in Atlanta, which is going to be this fall, October 9th through the 13th. That is the 242nd ECS meeting. We had extended the abstract submission deadline to April 22nd. But mark your calendars because registration opens in June of 2022. So if you can't meet us in Vancouver, we hope to see you in Atlanta in the fall. If you'd like more information about our meetings, you can visit electrochem.org/meetings. Now, I'd like to introduce today's speaker. Dr. Mark Willey recently joined Pacific Northwest National Laboratories, PNNL, following a 17-year career in private industry in the fields of process control, semiconductor, capital equipment, and most recently, semiconductor and battery materials manufacturing. As vice president at Moses Lake Industries, he founded and led MLI's Battery Materials Business Unit, which develops novel materials for non-EV US lithium battery cell producers. Mark holds a PhD in chemical engineering from Columbia University, where he focused on electrochemical deposition and modeling. He is also a graduate of Harvard University's Program for Leadership Development. In today's webinar, we'll learn and understand the current landscape of U.S. companies supplying materials and components for cell producers in the U.S., hear feedback from over 100 interviews with U.S. lithium battery companies from mines to car manufacturers, and walk away with understanding what is needed for the U.S. battery materials, equipment, and software supply chain to ramp production in the U.S. Again, we welcome your questions. Send them in at any time during the webinar using the Q&A function. Our presenter will answer as many questions as possible after the presentation. And with that, I'd like to turn today's presentation over to Dr. Mark Willey. Mark, take it away.
Thanks a lot, Shannon. Appreciate the intro. Great job there. And I, again, appreciate the help from the Pacific Northwest ECS, and especially Jay Shao, who has been a great partner here at Pacific Northwest National Lab. I'm going to just bring up my presentation here quickly and we'll get started. One thing I'll say is I specifically left this presentation somewhat short in order to get lots of questions and discussion going at the end of it. I'm much more of an interactive person in terms of these discussions than just having me disseminate information to you all. So hope to answer your questions and discussions. And I've also got my contact information on the screen, and you can always get a hold of me at PNNL as well with other questions. Okay, so this talk's going to be maybe a little bit different than most of you have had or seen in the past from ECS discussions in terms of its nature of being more focused on the market in the industry and the actual production processes within the battery industry. What we're going to do is I'm going to set up the discussion with just going through the market for lithium batteries, take a look at what's going on in the market. Then we're going to go through some of the challenges, some feedback I've gotten from a lot of these discussions I've had with the different materials and equipment and car manufacturers, and then finally finish up with some synergies that are in different markets that can help support ramping manufacturing in the US. So first I'll talk about the battery market and kind of go through and set the stage. So most people, when they talk about the lithium battery market, they focus on the electric vehicle market, which is definitely is a huge market within the United States and worldwide. But there's also this other market that is formed within the lithium storage space. And that's really this, what I call the non-EV, or sometimes I call it the niche market space. And I think it's very important to outline the differences between these two markets, because that really drives the differences in the types of companies that operate in the two markets. So in the non-EV space, you can see there's a lot of different players, all the way from aviation to defense, US defense, energy storage space, medical, consumer electronics, industrial. A lot of different players. And I think the biggest point here is for the non-EV space, you have to realize the amount of different types of formats for even a lithium battery is enormous compared to the electric vehicle space. In the electric vehicle space, obviously, I'm considering that the light duty trucks and cars. This space, most of the chemistries and materials are really focused on just a few, I would say, and the specifications for those few chemistries are very different than the needs of the non-electric vehicle market. So the other thing I'll point out, sorry, I didn't mention this, is the volume. I think the other thing you need to understand in terms of cell production for batteries in these two markets, the volumes for the cars versus the non-EV spaces is orders of magnitude larger. And that also drives some of the dynamics within the market. This is actually a slide I put together just simply to show the size of the markets, the difference in the market spaces for non-EV, with it being less than obviously 10 gigawatt hours per year currently in the United States versus 53 for the electric vehicle space. And the CAGRs for both of these markets growing pretty significantly, even the non-EV market growing at a 10% growth through 2030. The thing I'll mention here is I made this slide a few months ago, and it is just crazy how many announcements over the last few months have come out for electric vehicles. And so this 79 gigawatt hours per year of storage, I'm sure is smaller than it should be for 2030. But the point here is that you've got two markets. These two markets, you actually do have a significant amount of growth, even in the non-EV space. And it's not just dedicated to the electric vehicle growth. Okay, so when we talk about United States cell manufacturing, a lot of people know about the electric vehicle side of it. I put this slide together just to show some of the companies that actually operate on the non-EV and also the electric vehicle cell production space currently. I'll go through just quickly the left side of here. We've got the non-EV, and I also said startup cell producers. I think one thing to note on the left side in the United States is you have a lot of companies that are in the materials space that are startup companies that are actually launching into the cell production space to make it a enticing market or enticing business opportunity for them to get involved with. A lot of the materials produced just in the electric vehicle space are low margin products, and they require a lot of capital investment. So a lot of the companies that are smaller startups coming up in the United States see that and understand that they have to be also involved in cell production in some format. On the right side, it's a very different story. So you have most of the companies operating in the electric vehicle cell production are non-US or joint ventures with US OEMs. And kind of the odd ones here, and obviously this is not encompassing everybody, but not the odd ones, but some of the ones that are US based, obviously, are Tesla at the bottom there that supplies their own cells, but also receives cells from other non-US based companies. So very different market space in terms of who's involved with the market. And the big message here is that obviously the Asian cell producers are providing most of the know-how and manufacturing for the US OEMs. What's really interesting actually is if you start to step into the supply chains behind the OEMs to understand where the batteries are coming from. And because of the lack of manufacturing, or I would say not lack of manufacturing, but the lack of the size of manufacturing for materials and chemicals, a lot of the OEMs, just like GM, have had to rely on non-US based companies for a lot of their materials going into the cells that they're producing. So most of you probably know that GM has a joint venture with LG that's called Ultium Cells. And what they've had to do is actually bring in a lot of the supply chain from Asia. So you'll see a bunch of these companies from China, Korea, are there supporting GM and Ultium to be able to produce the cells. And obviously, ideally in the United States, you would have US production of materials for these cells just because of the supply chain and logistics problems that have happened lately, causing issues. But the reality is that if GM or any of the other OEMs are going to bring up the electric vehicle production in the 2025 or earlier timeframe, they just don't have time to rely on the smaller US manufacturing companies to ramp in that timeframe. And so the lack of kind of these larger materials producers have really put our OEMs in a bind. I think the other thing to point out is I'm just highlighting some of the midstream manufacturing here. But if you start to dig into the refined materials and raw materials, I just threw some stuff on this slide to show this, but you have an even worse situation, I would say, for that in terms of non-US produced materials. And we really need to start to think about how to solve that problem. And that's one of the discussions we'll talk about later. Okay, so what do we have in the United States for materials and equipment manufacturing? So again, I threw this slide together. It's got some of the players on it, obviously not all of them. And if there's industry companies on the call that want to get their name heard within at least my space, please send me your information. I can start to throw your information onto the different areas. But you've got actually a significant amount, I would say, of North American materials producers in the United States. And these are producers that produce anode, electrolyte, cathode materials in the United States and produce it for often smaller non-EV cell production. So the problem is not that we don't have companies that have the expertise and the knowledge of producing battery materials. Really, the problem is the size of the companies, or I shouldn't say the size of the companies, the size of the battery production materials space that the companies are involved in. And it's just orders of magnitude, like I said, smaller than some of the Asian folks who have, or Asian companies that have come up and supported the electrification in Asia and in Europe, which is going on right now. I have a little bit of information on some of the equipment and software producers on the right side of this slide, and also the recycling folks. You know, if I look at gaps, people always ask me the biggest issue with equipment or materials in the United States. One of the biggest gaps, I would say, is equipment. We don't have enough equipment providers, especially on the assembly side, where it's almost non-existent. I would say non-existent. And that's one of the big areas that we need to help understand how to improve. Yeah, and so on the next slide here, I'll just kind of get into some size, just a qualitative just showing of size issues and kind of how that unfolds within the supply chain for the OEMs. So if we look at an example of separators within lithium-ion batteries or lithium batteries in general, you can see we have actually two big companies or two significant companies in the United States, Celgard and Entech. And actually Entech announced recently a significant growth in their US presence over the next few years for separators. But the point I wanted to make here is that it's supposed to be represented in obviously the size of these lines, is that the materials going to the US cell suppliers from the material providers is much smaller than what they're getting from the Asian companies like SemCorp right now. And the main point here is that we're, you know, one of the big risks within the United States right now is finding how we mitigate that that issue. How do we bring that manufacturing back to the US and have more of the US companies supplying local materials to not just the non-EV space, but also the EV space. Okay, so let's jump into the needs or the situation in the industry and why these material suppliers or equipment suppliers are not growing their businesses to support that. I think one of the first things I'd like to go through with people is just and this is a very simple product life cycle example, but I think it's very good to ground ourselves in understanding how a material or product rolls out from an industry such as a material supplier that's providing materials for a cell, lithium cell. There's many different steps. This is a very simplified product life cycle I'm just showing, and obviously the years are different for the different parts of the industry. But in general, when you start a product development, you do obviously a large analysis to understand if you want to get involved in that market. That often takes, I mean, it could take 2 days, it could take 2 hours, but often a year to 2 years is a good a time frame for the analysis to happen. After that, there's a phase gate where you pull the trigger on whether you actually want to invest in that segment or product. And at that point, your investment goes from a small analysis to a high capital investment. And that's where you're buying all the capital equipment, you're ramping it up, you're getting the facilities all set up to actually do manufacturing. One of the areas that most people don't think about in terms of making products is qualification. Qualification is a big area that that takes a lot of time, especially with the OEMs. I put greater than 2 years. Obviously, that's much greater depending on the different car or consumer electronic application. It varies dramatically. But the point is even after you've got the whole production site built, you have to factor in some time to actually qualify the materials. And then after that, you have to actually produce the materials. And so you've made all these high investments and a lot of risk in the initial part of the project. And then you have to actually run the plant for a certain amount of years to produce enough material to have a good return on investment. So if we add up all these years, you can see that the time needed is just dramatic compared to some of the timelines for electrification in the United States. If we talk about a lot of the OEMs bringing up applications in, let's say, 2025, or obviously before, there's been a lot of announcements of new EVs recently. These timelines don't match. The timeline to actually, even if we have already done our analysis and understand we want to be in the battery market, if we're a materials or an equipment producer, we still have a long time until we can actually start making money and producing product. And that timeline is just not matching with the timelines that are required from the OEMs at this time. And some of the key points here is that at the bottom is that simply there's a large investment and high risk needed initially, and there's a long time before that the actual money comes back and pays off that risk. And in general, I will also say that companies like large markets, but they also like a gradual production ramp. And that's specifically to mitigate some of the risk that goes into whether you're actually going to get qualified or be able to enter the market. And right now, as I move on to this next slide, that is not the case for if you're going to jump into the electric vehicle market. If I put this simple graph together, and I'm sure there'll be some comments about the linear or growth of demand for materials and cells in the United States versus an exponential. The point of this graph is actually not to be quantitative at all. It's simply to point out that there's a huge mismatch, even in 2022, our current time frame, of the size of the materials available within the United States and the needs of the OEMs across non-EV and EV space. And that mismatch causes a lot of issues for suppliers trying to come up in the market. One of the big issues is that, as I said in the last slide, is just this time frame for getting involved in the market. And if you're a material supplier and you have a material that can be put into a lithium battery, even if it's a novel material, it performs really well, you still have to be able to produce that and be able to grow at the rate that the industry is growing at. And that means you have to do significant, hundreds and hundreds of millions of dollars of investment to be able to produce at that level. And that hasn't been something that a lot of the companies in the United States have been able to or willing to do, either because of the capital is not available to actually ramp that production, or the risk is too high. And I think one of the big key things here, and I point this out at the bottom here, is I think when you talk about materials and you talk about equipment, especially for the battery space, and this is a little bit different from my background in semiconductor, but especially for the battery space, you're talking about low margin products, okay? You're talking about products that are already under pricing pressure to get cheaper batteries made. And so if you're even a large chemical producer and you're wanting to ramp into the space to gain revenue, you are very hesitant to do that because the capital investments needed just don't make the small margin or the net profits make sense, even in 5 to 10 years. The other key thing is that even if you ramped your current technology, your current product, how do you know that the battery format's going to be there and it's going to be the same in 10 years? You just don't. I mean, there's so much dynamic in the market right now that the risk for entering the market, whether it be high capital cost, the technology evolution, like I just talked about, qualifying, maybe you have the right material, but it's just can't hit the specs. So you brought up a whole plant that just doesn't qualify. These are all issues that are steering a lot of companies away from actually getting involved, or I should say US companies from getting involved in the materials and equipment space, and has really allowed the Asian companies to come in and take over that space currently. Again, this is really a summary of the challenges. On the left side, I've already talked about most of the challenges. I'm not going to go through this too much. I didn't talk about one of these challenges, which I just want to highlight at the bottom here, which is people. One of the biggest issues, and I should have illustrated this before, but is this the amount of people that we're going to need to actually staff the factories, not only for materials and equipment, but also for the cell production. We don't have the workforce right now. And a lot of the issue is that we have to ramp that workforce in a short amount of time. And so there's a lot of efforts from different areas within the DOE and within even PNNL itself and across the United States to understand how we can do that. The other key point I want to point out here, and I put this in the needs, is we need to make sure that companies that are operating within the United States, if they're foreign companies, are operating to the same standards as US companies. We shouldn't hinder the US companies for doing a good job at operating with fair labor practices, with low carbon footprints, with good environmental practices. We shouldn't hinder those companies with foreign companies coming in and being able to do that overseas by getting around these different issues we want to have as priorities in the US. We need to make sure that companies uphold those policies. And that's another area that I believe is a big need for reducing the risk and allowing for US companies to be the next dominant provider for the next generation of batteries. Okay, so what do we need? Again, I kind of went into this a little bit. Long-term contracts to de-risk the investment that some of these materials and equipment companies are making. So these would be things like offtake agreements for some of the OEMs, whether it be electric vehicle or consumer electronics. I think the other thing is a ramped long-term contract is really what a lot of companies are looking for. They're not necessarily looking for millions of liters or kgs of material to produce. You know, a lot of companies want to come in as secondary suppliers and be able to ramp and show their quality to the OEMs. Permitting is a big issue in the United States right now with getting manufacturing set up. This is across the board. This is one thing that a lot of the Asia countries actually do really well from my experience working with a lot of even the Chinese government. There is a lot of challenges, obviously, if you're producing materials in China, but one of the things they do is they have the ability to quickly permit and approve projects that you're trying to work on. Talked about workforce development. That's a huge thing. We're going to need a huge workforce for not only the cell production, these gigawatt hour factories, but also the materials companies that are going to come up and support it. We need areas, and this is an interesting point and an interesting synergy for some of the national labs and also the DOE, but areas where we can help as a government organization qualify and support new materials so that if the OEM is very interested in a material or a cell, but doesn't have the time right now to support qualification, that we are able to actually qualify materials and cells in the United States and show the end users that they're actually good materials and qualified. And this will be something I bring up actually towards the end of my talk as I talk about more things involved at PNNL, especially on the grid storage side. Cheap capital, we saw yesterday a huge announcement from the DOE on capital support. The US companies, again, are lacking in terms of capital equipment, and there's a high risk. So having cheap capital, either from grants from the US government or from the loan program, these are huge things that are needed by materials, cell producers, most of the industry to de-risk their investment. The last thing I've already went over, which is a level playing field with foreign companies operating in the cell production or in the lithium battery space, and making sure that the US players that we have are not operating or don't have to have unfair competition from abroad. Okay, the next two sections I'm going to pretty quickly fly through, but one of the interesting ways we can solve this problem, I've explained a lot of the issues and some needs from what we need to do, but one of the things I always think about is what do we have in the United States and how do we utilize it to be able to support battery manufacturing? And one of the areas is, or I should say two of the areas that we do have in terms of manufacturing in the United States is semiconductor manufacturing and pharmaceutical manufacturing. And I think there's a lot of synergies between these markets and also the battery markets in terms of quality, high, strict specifications, and a lot of the similar materials actually for the three markets that we can utilize to help support ramping manufacturing. This slide here is just supposed to call out the fact that you've got these two big markets. These are not insignificant markets. They're not small markets compared to the battery ramp that's going on. The left side here, I talk about semiconductor market and the exports out of the United States and for a lot of these different areas. But if you look at even the semiconductor market for $46 billion in 2019, huge amount of money and production going on in the United States. And the bottom graph here just shows some dots of where a lot of the different manufacturing is happening. And I'll also point out here, I think most of everybody knows, but as the battery manufacturing ramps in the United States, the semiconductor is also ramping at the same time. So you've got these two huge markets going at the same time. Pharmaceutical, everybody knows pharmaceuticals mostly because we use them every day. And they're common names like Pfizer, Johnson & Johnson, and a lot of these other names. But the point here is also we've got a lot of large chemical and materials producers in the US that are doing pharmaceutical materials and end-use products. So we have these two huge adjacent markets, and the key is to be able to utilize these two markets to drive growth in manufacturing for batteries. Because the question is, how is this actually going to happen, or how would you do this? I'm a copper guy originally in terms of deposition, copper deposition. I think one of the interesting examples is looking at copper and how it flows through from a mining perspective all the way through midstream and then flows into the industries. there's a huge synergy with copper in terms of if we support midstream and even mining. We have a lot of mining in the US, but if we support the midstream manufacturing of copper and we bring a lot of that back to the United States, it actually supports not just our battery manufacturing in terms of the copper anodes that are used or current collectors, but it also supports a lot of the semiconductor, I should say a huge amount of semiconductor manufacturing processes, and also pharmaceutical. And these are through the plating solutions used in semiconductor. Again, I mentioned the foils and the battery industry and the catalysts and the pharmaceutical. There's a lot of plays for, there's a lot of stuff already going on in the United States for copper recycling. And then, there's a lot of opportunity here for smelting and refining advancements in technology. And I think that's another area that we look, especially at PNNL, are looking at programs and opportunities to enhance midstream manufacturing, novel midstream manufacturing processes to help companies bring up manufacturing that traditionally was a more dirty, I would say, process, and utilizing these new technologies that have been developed over the last 40 years to make it something that we can do in the United States. There's companies already doing this in terms of jumping into multiple markets in terms of, I'd say, bridging markets across semiconductor and battery materials. Applied Materials is a good example. There's many other companies that are doing this. And again, if there's companies on this call that want to highlight their different work, I'd be happy to talk to them. But Applied Materials obviously operates heavily in the semiconductor capital equipment market, produce a lot of equipment for semiconductor, but they also operate in the battery market and are starting to get more involved in that in terms of their coating tools. So I think the main thing I want to say here is that we do have companies that are already starting to look at these other markets, or so I should say the battery market, that are involved in the other semiconductor and pharmaceutical. I think one of the gaps or one of the challenges here is just explaining to, maybe not to Applied Materials, but to other companies that operate in these different manufacturing markets, how they can get involved and what materials that they produce can be utilized in the battery market. A lot of times, these companies are focused on one area and they don't have the view of the other areas. And that's another area that I believe that us as a national lab and other government agencies can help these companies just see what kind of markets are in the field. Okay, just lastly here, I'm going to show just 2 slides on PNNL to explain how we at PNNL can help with the ramping of this manufacturing. I think one of the big things that we want to just highlight here is in 2023, we'll be finishing the completion of what we call the grid storage launch pad. This is a facility that's 85,000 square feet that we're bringing online to help systematically and validate new types of grid storage technology. It's basically doing exactly what we need to do that I've highlighted in terms of helping qualify technologies so that the OEMs can see a low risk in utilizing them. So we're really excited about this, and it's should be operational within a few years here. The other thing, outside of even just grid storage, is we do a lot of work on batteries at PNNL. We do everything from stationary, like I just mentioned, with the grid storage. Even before that building is online, we have a lot of work going on in terms of deployment, analysis, development. We also do a lot of work in transportation. We have, we lead the Battery 500 consortium. Jay Xiao has been instrumental with Jun in ramping the efforts there. We have a facility to do pouch cell, I wouldn't say manufacturing, but pouch cell development and characterization. And then we do a lot of different other novel types of batteries. One of them is actually this fish sensor that we have, or tag that's been rolled out recently, but lots of obviously interesting new innovative battery technology coming out of PNNL. So I'll leave you with just the comment that if you are interested in understanding our capabilities at PNNL, or if you want to get more involved with thinking about consortiums or programs that you think would be a good fit to help support US manufacturing in the battery space, feel free to reach out to me. With that, I'll wrap it up.
Great. Thanks for that wonderful presentation, Mark. We have a number of questions in the Q&A
Okay.
that have come through. So I do want to share my screen just so we can have a slide up for the
I'm going to
background.
stop sharing then, Shannon.
You're good. I'll take over.
Okay.
There we go. All right. So let's hop into the question and answer section. I also, we've got Jay on the phone, who is also with PNNL, and she is the chair of the ECS Pacific Northwest Section, actually one of the founding and chartering members of the Pacific Northwest Section. So she'll be here and jumping in on the Q&A as well. So Mark, let's start out with one of the first questions that we have received. So coming from EC Power, have you looked into what capacity per year the US versus foreign suppliers have to build dry clean rooms?
I haven't. I have not, so I don't want to comment too much on that.
Gotcha. Okay, no worries there.
No problem.
And one of the very first questions we got was from Celine Gross, and I apologize if I mispronounce any of these organization titles. Will New Zebang, Semcorp, or Ilgen set up shop in the US? What are your thoughts?
Yeah, so that's a good one. So POSCO was actually the big one, and they've already set up shop, and actually not in the United States, but in North America and Canada. So yes, they're going to have to. I think localization of production next to the cell manufacturers is something that the OEMs are basically saying they have to do, and you're already seeing that happen. So there's a large amount of companies that are being, I don't want to say dragged over here, but pulled over here.
Gotcha. All right, and I think you addressed some of this earlier regarding supply chain and raw mining. But Darren Dale asks, how much of a factor do you think the dominance of Asian countries like China, who dominate the supply chain for raw mining of the metals required, restricts onshoring in the US?
I think, the answer is that a lot of the processes they're running in Asia, like I mentioned, are older, and they've been now I will say that China's doing a lot better job at kind of coming down and handling the environmental issues. But I think there's a lot of opportunities. Like I said, there's a lot of novel refining methods that are coming online for that industry, and I think where the mining industry has been a little bit slow in the past to transition to some of these newer methods, I think we as a country can help support them to bring those online if we have different incentives or policies that can do that. So I don't think it's impossible for us to do that. I think the other thing is I didn't even mention this, but I mentioned it a little bit in the talk, is recycling. And so, I've talked to a lot of the companies that are more on the materials and recycling side, and there's a lot of recycled copper in the United States. In fact, I heard somebody say there was a surplus. So there's a lot of opportunities to not have to utilize necessarily mines 100, significant percent to support to support those applications. I think we can do a lot of recycling and novel recycling in the US to help support cell production.
Okay, great. All right, I'm going to bounce around here a little bit. So Dr. Igor Barsukov says, he says, thanks for a great talk. He says, we are seeing foreign cell makers establishing their production in the US. Are you seeing them bringing their vendors along? Meaning, are foreign material suppliers establishing their production plants in support of cell manufacturing? One of the examples he gave is he recently read that an Australian graphite maker, Volt Resources, has landed some of its operations on US soil. Are you seeing many of those examples across material suppliers as well?
Yes, I'd say 100%. I'd say almost all of them. I think you have to understand that if you're a company, and let's just take, I'll take a hypothetical company so I don't get yelled at. But if you're a company in Korea and you are producing high volume cells in Korea, and you have your whole supply chain set up with other Korean partners, and then you come to the United States and you set up in the United States to produce cells, and then you look around in the United States, you've got two issues. I think one issue is you don't have the relationships. I think people don't understand, or not people, in general, it's having those relationships and established respect for other companies that you've already worked for, getting that done in a short amount of time is not possible. So if you're coming over, you've already got your established relationships in Korea with your other suppliers that you've relied on for years to support you. You know that they come through for you. You're going to bring those same partners over. And so, yes, the answer is that almost all the companies I've talked to, that is what's happening. And I think there's a play, though, for the United States, not in the, I would say, the short-term production of materials and cells, but the longer term, I would say late 2020s, and bringing up production in the United States. I think right now what we need to be doing is building relationships with the cell manufacturers that are coming over from Asia, making sure that we have an ability to supply those companies with materials and equipment for the later 2020s. And the OEMs, just to be clear, that Ford and GM and all these other OEMs are 100%. I mean, obviously they want production in the United States. That's what they want, and so they will be driving that vertical integration in the United States, similar to what Tesla, obviously, has done over the last 10 years, 20 years.
Right. I've got another one from earlier, from Ted Lister. Do the low margins encourage the vertical integration we are seeing with Tesla and others?
Oh, low margins. Yeah, I mean, I think the answer would be yes, because the vertical integration is specifically happening because they have to be able to reduce the cost within the different steps. So well, it's not just the cost, but the risk. So if you look at, I think the big thing, I didn't mention this also, is business continuity. So BCP processes, making sure that you can actually get material consistently, is one of the reasons these companies are all going vertical. It's actually interesting. The auto industry originally was vertically integrated, and then it went out of vertical integration, and now it's coming back. But definitely getting a low cost, vertically integrating to reduce costs, localization, those are the reasons why. The low margin from material suppliers, that's definitely one reason they're vertically integrating, is that they see they have to do that in order to entice the material suppliers to or the materials production to come up.
Great. And I think we pretty much hit on all of the other questions that are in there, a lot of them talking about the Asian markets and whatnot. So is there anything that you may want to wrap up with, or if the audience has any last minute questions, please feel free to submit them. We've got a few minutes left. But Mark, I'll turn it over to you in case you have anything you want to wrap up with.
Sure. Yeah, I think the main thing here is that there's a lot of challenges right now with ramping manufacturing for batteries and materials and equipment. And I think we're going to have to, over the next 10 years, we're going to have to do two things. We're going to have to support the current generation of lithium battery production materials, and we're going to have to hopefully leapfrog in terms of production and manufacturing on the next generation. It's not necessarily a bad thing that we're coming into this late in terms of the United States. A lot of times during product development, you wait for kind of the initial market to kind of settle down and see what's going on, and then companies will jump in and leapfrog. So I've seen that a few times in my career, where products have come, or companies have been really early in the market and have thought, and you would think they would dominate the market for the whole lifespan of that technology. But the ability for the market to settle down and for other companies to see where the market's going, and for batteries, that's like the late 2020s. If there's a way for us to enable manufacturing of novel materials or novel battery types to capture the EV space in the late 2020s, that's where we need to also support the ramp of manufacturing. So we've got this challenge of supporting the current ramping of manufacturing, current generation, and then hopefully leapfrogging and bringing back a lot of the materials and equipment manufacturing for the next generation. But I think we have the ability to do it in the United States, and we are definitely on track in terms of the technology development to do it. It's just a question of making that technology turn into actual manufacturing.
Great. Well, thank you. And so with that, we'll wrap up today's presentation. I just have a couple of other items. So Mark, thank you again for an outstanding presentation and an engaging Q&A session. And thanks to Jay for joining us today. And with that, I'd like to highlight the ECS webinar series, which has some upcoming webinars for the community. Again, we have this webinar series monthly, and it showcases distinguished speakers and members of the ECS community. Our next presentation is on May 25th, 2022 with Kevin Moeller on exploiting the synergy between organic synthesis and electrochemistry. If you'd like to learn more or to register, visit electrochem.org/webinars. And we're also accepting future webinar topics. So please feel free to email me, shannon.reed@electrochem.org, with your ideas. And then with that, again, one final thank you to everybody that attended today, to Mark, to Jay, and coordinating in the Pacific Northwest section. The recording of today's webinar will be available on the ECS YouTube channel within the next week or so. We encourage you to recommend the webinar to your colleagues and share the recording on your social media accounts. Make sure to tag ECS. And with that, thank you all for joining us again. The webinar is now over.